Hello, I'm Reza Lami, and in a series of videos I'm going to explain you how to model a pre-stressed concrete beam using ANSYS Mechanical APDL. Pre-stressed concrete beam is a complicated structure, so I think that the tips and tricks I use during the procedure of the modeling can be useful for you in other modelings, like for example steel structure, truss structure, and so on. You can see the ANSYS menu here is a tree-like menu. It's for creating model, solution option, and also output. It's a step by step. So for creating model, I have to go to this part. For creating geometry, I have to go to this part. In this video, I'm going to just focus on geometry. Here you can see the ANSYS menu here for geometries. Also create me nodes and elements in addition to geometry. These are our geometry elements: volumes, lines, and areas. So I want to start with volume because my pre-stressed concrete beam is a volume. It's something like a block, a simple rectangular block, and you can see that I insert some data here. These are the two corners of a rectangle, and it automatically create me a block. I choose millimeter because the combination with the Newton leads me megapascal for pressure. That is very useful and used in lots of engineering source, and it's really good for analyzing. So I prefer to use Newton for forces and millimeter for length. So you can see that it create me this volume. It's ready. I can do everything with this volume, and also I can edit it in this menu, like with modify. I can move this volume, and also here I can scale, and also I can mirror it, and also there are more options here in booleans, extrude, lots of options here, and you can see it create me lines and areas automatically. So I usually don't use this menu because it's not so user friendly, and I have an easier medium for this, and it's AutoCAD that is much more user friendly. You can see AutoCAD workplace here, and I created and sketched the you can see in drifting and annotation. I sketched a plan of my concrete beam, pre-stressed concrete beam, with some simple objects like line, move, trim, and other things, mirror. So it's easy. Everyone know how to work with AutoCAD, and I have to transform them to a volume. I have option something like extrude, but it's really simple. Here is you can see the extrude, but I don't usually use it, and I tend to use press pull. Press pull is an option that automatically distinguish a closed area, and I can extrude my model as long as I want. You can see I can easily. So I can easily move my volume. It's a 3D move along main directions, and also I can rotate along main directions. These are optional. These are additional options in 3D mode, and also I have 3D mirror here, cut, lots of options for modifying. And also good thing is that I can use Control and Z to undo my change. So it's really easy and user friendly. I can see that I created some volumes here before, and I assembled them with these simple objects. I try to divide my structure in several partitions because I have different stress concentration in this part of my structure. It's the middle of the span rather than this part. So I need a dense mesh, more dense mesh in this part, and in machining objects I have to define a different mesh size in these parts. So you can see that another thing is that I cut my volume and it's not a proper beam. I cut from the middle of the stem and along the symmetric axis. It makes my model smaller, and also my output file is smaller, and it ease the convergence and increase the solution speed. And I strongly recommend you to use the symmetric specification in your modeling if it is possible, and for example your model and your loading both should be symmetric to use these kind of tricks in your structure. So you can see my model here, and I have to transfer my model to the ANSYS medium. I have to export my volume to a file that is compatible with ANSYS, and these are two files for this aim. These are ANSYS or SAT and IGS and IGS. IGS can work for both volumes and lines and areas, and but ANSYS is just work for areas and volumes. But IGS doesn't work well for volumes. I tend to use ANSYS for volumes and IGS for lines. My tendons are lines, so I can export, and I can use, for example, layers. I created my tendons in a different layer, so I can turn it off. So if I select my volumes and press enter, create me the file. You can do the same thing for the tendons using IGS. So I have to go back to the ANSYS medium and transfer that file to the ANSYS workplace. We are back in ANSYS workplace, and I want to import that file. ANSYS is set also. Ramos 1 here. These are my volumes. It's easy to, it's ready to use. It shows me areas, but you can see there are volumes, and you can see that it's create lines automatically for these volumes. You can do the same thing for your tendons using IGS file. That's it for this video. I will discuss you the model procedure in further videos. Thank you for watching. Don't forget to subscribe.